Hello, everyone. Hitting the home stretch. As the expo hall closes, we have more and more people filing in for a very exciting talk called Space to Think. It's by Jody Medich. She is a UX designer. I caught part of this similar talk at SVVR a few weeks ago, and just really fascinating stuff about how VR changes our perception and how we can think about designing UX now that we're immersed in a 3D environment, a 3D world, and what that means to the way we interface with that environment, how we see it, how we interact with it, and it's just really fascinating stuff. So I'm very, very pleased and excited to welcome Jody to the stage. Let's give her a warm round of applause.
Hi, everybody. I am Jody Medich. I'm a UX designer, and I'm currently looking for my next big challenge, so if you have any ideas, let me know. I've started working in AR at the company that I co-founded, Kicker Studio, back in 2008. We specialize in natural user interface and R&D for companies like Samsung and DARPA and Intel and a lot of other really cool collaborators. And then Microsoft convinced me to close it down and come be the principal experience designer on their analog platform, which you all know and love as HoloLens. After that, I left and went to collaborate with David Holtz and his team at Leap Motion, where I was the principal UX designer. We created best practices, some really great widgets that developers can use to drop into their VR applications and allow users to control their VR applications with their hands. So it's been a lot of fun. And today I'm going to talk to you about some of the things I've learned over that time, specifically around the opportunities in space, right? I believe that we are on the cusp of a spatial computing revolution, and it's all come about because of AR and VR. Now, because I'm a UX designer, I want to first start talking about the human side of this, and then I'll switch into the technology side of it. Humans are inherently visual creatures. We process the world through visual. In fact, we communicated visually long before we were able to communicate through language. So much so that if you take your hand and put it on the back of your head, that's about the amount of your brain that is dedicated to processing visual information. Your linguistic center is it's not very big. It's really small in relation. So we're visual creatures. And that's really important. We can look out the window and we can tell a lot about our environment just by the visual information we get back, right? I can look at the trees and I can see the wind is moving in a specific direction. I can tell if it's sunny or rainy. I can tell if it's cold or warm. And it's all coming to me without me really having to think about it. It's just things that I notice without even really having to consciously think about it. And that's because we are such visual creatures. Even our language is visual, right? And it's spatial. Without space, the letters just become a string of characters that are kind of strung together on the screen. They don't really make a lot of sense. And that's because our visual cortex evolved in a 3D dimensional world, right? Space is incredibly important to us. So much so that spatial memory is free. We don't have to do much to understand the space around us. It's innate in us. We are constantly creating spatial cognition or spatial awareness of the world around us, right? I know where things are because I know where they are spatially in relationship to me. I am horrible at remembering where my keys are. But if I have a space where I put my keys, I'm more likely to remember where they are. And in fact, that's the only way that I can ever find my keys is if I remember to put them in the key box. So spatial memory is free. And we use space in a number of ways to make sense of the world around us. The first is spatial semantics. I'm a designer, so I spend a lot of time with sticky notes and a whiteboard and a lot of people in a room generating sticky notes that we then put on a whiteboard and we organize spatially. And in doing so, we put them into these buckets. And in putting them in those buckets, we start to understand how all of that information plays together, the relationships between different objects, and we can start to see patterns about all of it from afar. So the way that we arrange items in space has a lot of meaning. There's the timeline, right? Things in the past are on the left, the most recent things are on the right. There's spatial bucketing, like I'm talking about. There's even alphabetical order, which is also a spatial system. So there's a lot of different spatial semantics that we use in our world. The other is external memory. I mentioned this earlier with my key box. The other way that I use my key box, though, is if I need to remember something to take with me the next time I leave my house, I put it next to my key box, and then I remember it. I don't really have to think about it too hard. I leave myself to-do notes and sticky notes, and I stick pictures of loved ones in certain places in my world just so that I can remember those things or remember those people. So we use space as an external memory system. The other way we use space is to tell the difference between objects. You can tell the difference by looking at these two objects. You don't even need to know that the one on the left, is War and Peace. You can just tell by looking at it. Or it is, sorry, longer than the piece of paper. You don't need to know that it's War and Peace. You just know it's bigger, more in depth, more of an effort than that blank piece of paper is. I can tell that because they're dimensionally different. And I can tell a lot of information just based on an object's dimensionality. And the way that I make sense of all this space, in addition to my visual cortex, is by moving about in space. I talk a lot about embodied cognition. Embodied cognition is really important. It's the way that we think with our entire bodies, right? So like right now, I'm walking around on the stage and talking to you. It's helping me to process my thoughts. It's also helping me to alleviate some of my anxiety about talking in front of a big group of people. We also see like standing desks and things like that where movement helps us to process thought. Well, it also helps us to understand the environment around us. It's our proprioception that helps us to understand an object's relationship to me. Parallax helps me to understand one object's relationship to another. And parallax only happens when I move my head or I move my body. So these are the ways that I create my sense of space. But here's the problem. We are living in a flat 2D monitor space. Right? We are inherently visual creatures, and Xerox PARC back in the 70s realized that we were not going to get very far if we required our computers to be entirely based on linguistics. So they created the GUI. They knew that humans are visual creatures, and that by giving some sort of visual information rather than having to remember a bunch of linguistics, we would be much more efficient at running computers. The thing is that when they did that, data was mostly just strings of like linguistic information. We didn't really share photographs the way that we do now. We didn't share 3D objects the way that we did now. It was all still kind of a language-based system. So they created a spatial system, but it's about the same as giving me just a string of characters with no spacing, right? There's no spatial structure really there. The spatial structure that does exist is my desktop, some files that I put some folders that I put files in. Those things can change at a moment's notice without my control, and I have no way to make them go back the way they were. The spatial arrangement is really ephemeral. It has I can't really rely on it to create a sense of spatial cognition. So let's change that. We already know that by allowing users to spatially organize their tasks, their digital tasks, we can improve productivity as much as 40%. Here's the picture of the table back there, the one that's running the show right now. And you can see they have all these different monitors set up, and they're all doing different tasks. And that's because if they ran them all on the same thing, it'd be a really confusing mess of all these different layers happening at the same time. But they've spatially arranged it so that they can just turn, 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 and do those tasks. And in doing so, they're improving their productivity exponentially. So lots of examples exist of how we can improve productivity through spatial means. What I want to talk about is the problems that we have with the existing OS without this spatial knowledge, right? Every time I interact with my OS or my UI, I'm creating an interrupt in my flow. So let's say that I love Google Docs. I do a lot of my work in Google Docs. So I'm constantly in my browser. and I'm switching between tabs. Unfortunately, every time I switch between tabs, I'm creating an interrupt in my flow. And those of you that are familiar with interruption costs in engineering, you know that this is going to be a real problem. In fact, in looking for address online in 1 hour, I did 288 UI switches. So every time that I create an interrupt, I'm looking at anywhere from 3 seconds to 30 minutes in interruption costs. But we can save that. We can eliminate a lot of that wasted time just in allowing users to set up a spatial structure to their tasks. So the opportunity is VR, right? Spatial memory is free, even in virtual worlds. It's been proven time and time again that people can create very elaborate spatial memories of virtual spaces. In fact, we can even do this without virtual spaces, right? Like, memory palaces are incredibly effective at allowing people to quickly and easily remember a lot of information. And it all is based on creating a spatial memory of a non-existent space. So now we have a system where we can create all kinds of spaces to allow users to create their own spatial structures. We can do spatial semantics. So here's a product that I worked on at HoloLens, where we were trying to figure out how people could organize their applications in their real-world environments to create that even more efficient use of our digital space. So I'm already building on my existing spatial memory of my existing spaces, and now I can put my digitals. This is the equivalent of putting important digital things next to my key box so that I don't forget them when I leave in the morning, right? So we can create this virtual spatial semantic over my existing spatial one. And because it's technology, I have magic. So I can create dynamic spatial semantics. I really highly recommend that you check out things like Pivot by Live Labs and Sandance by Stephen Drucker at Microsoft. They're looking at different ways to map information. Right now, when we go to our file system and we want to sort something by name, size, or type, there's really only 3 ways that we can do it. We can only pick one of those 3. We can't do all 3. We can't cross-reference 2 of them. We can only do 1. But things like Pivot and Sandance are looking at the ways that you can map multiple parameters onto the same bit of data to find the one element that you want. So Stephen Drucker's Sandance, what it does is it takes voting data from the elections, Obama, I believe it's the first Obama election. And you can map it in a number of different ways. You can put it spatially over the country so you can see how people voted. You can sort, the colors can become different things like it can be Republican, Democrat, but you can also look at financial structures so it can create this much more rainbow-looking display. And then you can change the sort method at any time. And the movement between those 2 sorts is really, really shockingly helpful to understand what those little bits of data is. So we already know that we can create dynamic dimensionality. So I could create my spatial structure, and then I could say, oh, show me it by time, and it could go into time. And then I could say, oh, never mind, go back to my spatial structure, and it would automatically do that. But because we can start to map multiple dimensions or multiple parameters on a grid, we can also start to create dynamic dimensionality of digital objects. So back to my War and Peace and a blank piece of paper example. When I see these 2 things in digital space right now, they look pretty much the same. Me as a user, I have to bring a lot of working memory to the table here, and I have to know the difference between these 2 objects. I have to know that War and Peace is this lengthy historical novel that I've never actually managed to get through, and the blank piece of paper is just that, blank piece of paper. But if I don't know that beforehand, if I see these 2 icons, I don't know what they are. I don't know the difference between them. They look basically the same aside from their colors. But let's say that we took a 2-point perspective approach to this, and we mapped a parameter along this x-axis and the y-axis, right? So I could say, show me history by file size. And the objects that are bigger and more historical would pop forward, whereas my blank piece of paper that is very new and minuscule in size would fall back into the background. But then I could also say, no, that's not what I'm looking for. Show me favorites by time spent, right? So show me the things that I love the most based on the time I spent on them. And as I just admitted, I've never actually read War and Peace, but I've spent a lot of time looking at that blank piece of paper. And so those two objects become fundamentally different to me in this example. And then I can snap them back to being their nondescript little pieces of iconography, just like that. So these are all different ways that we are already starting to use space in computing. And now we have VR, right? So we have an infinite canvas of space to work with. But we need to allow users to create metaphors for that space, ways to use that effectively in the same way that we do in the real world, and hopefully start to bring about the spatial computing revolution, which I believe will make us all much more efficient and kind of like superheroes. But I read a lot of Batman, so anyways, thank you. I guess we can open it to question and answer. I can't see, though. Ah, there, okay.
Sure. Well, first of all, extremely beautiful. So I've won through a few awards at hackathons for spatial visualization.
Awesome.
So my project was like 3D visualization of Wikipedia, where we have like a coordinate system. So you have like Obama's articles right here and White House is right here, but the cats are way out there with the dogs. And I'm also interested in some open source work on top of that. So I just wanted to ask you, what are some of the craziest things that you kind of presented a few samples, but I have a feeling that you have a lot of things on your mind. What are some of the fun stuff that you've been exposed to?
Oh, well, I did get to work a lot with MSR, so a lot of stuff that I really know, but I think they'll come and take me out if I tell you about. But there's some really great stuff done by Mary Zawinski, which she's my hero. Mary Zawinski, she's at MSR. And she did a lot of really interesting experiments with placing digital objects in physical locations. And she found, things like unique architectural elements in the space, like a corner or an X or something. If somebody put something there, they are more likely to find it. Another really cool experiment that I saw was looking at people were allowed to spatially organize icons of things that they commonly use. And then they used it for, I think, like a couple weeks. And then they took away the visual of the icons, and it was just spatial. And then they took it away from them for about 6 months. And they brought it back to them without the visual information of what those icons were. And people were instantly able to find things like their email app or their, it was because of the spatial structure of that was so important to them. So
this cabinet in your desk versus that cabinet.
Yeah, exactly.
It doesn't need an icon picture on it.
No, you just know that that's what that is. And so I've seen a lot of experiments like that that really just make me so happy.
Just to follow up. Do you think that this could be kind of like an entirely new desktop user interface for the future of computing, basically?
Absolutely. I think that we are selling ourselves short if we aren't thinking about that. If we aren't thinking about spatial implications of operating systems, they have to be. It just improves productivity so much. I don't understand why we wouldn't.
Does that, from your perspective, come into like kind of parallel computing? And do you think about that in that context? Because that made me think about like, well, we have like these GPUs and these things like that, but to get a three-dimensional kind of computing operating system, is that something that, I know HoloLens, for example, had to do a lot of innovation with its actual processors.
Yeah.
What would you say to that?
Yeah, there's so much stuff that has to happen, right? Like we really need to get things like LEAP involved so that you can use your body to understand your space. We need different types of processors for doing these types of things, right? We're not just displaying one set screen, right? Print's dead. There's no more edges. It's just out there. So this is going to require a lot of work.
Thank you.
Thank you. Hi.
Hi. So I totally agree that we are first and foremost spatial and visual beings. And I really love this concept of using space to organize and tackle complex tasks. And my question is, do you see limitation in complexity where you can actually use things like, for example, using spatial proximity to put things together which in some way relate to each other. But I can see that after a while, like if there is an object, sorry, a thing, concept, something, which has got a lot of relations to other things, then you just run out of space.
Yeah.
For example, I don't know, maybe I should talk to the guy who put the question before me. For example, Wikipedia has got a lot of links from individual pages. So if you want to map all of these pages, you simply get clutter. And how do you find that?
I think that's where I was getting at with the dynamic nature of digital space. So some of those connections over time become less meaningful to you. Others become more important to you. Different situations change which objects are actually in proximity to that digital object, right? Like if I'm looking for, let's say I'm looking at Africa, and one lens I want to put on it is, well, the game show Survivor went there, so I want to see that cut of it. Or I want to see, I want to see the natural landscape of Africa. Or I want to see, right? So there's different parameters that have meaning as to what is proximate. And then there's also the absolute, right? Like Africa is next to Asia, is next to, right? There's the, so because we're in this magical digital space, we can have both. We can change it depending on our needs, and in that way, not only do we have like physical space, but we have kind of this conceptual space to play with as well. Does that make sense?
So if I understand correctly, you fight clutter by allowing the user to choose what they want to see, or
yeah, you could do that, or
customization.
Yeah, customization, or the dynamic nature of data, right? Like, if I'm creating stacks of information, so for example, if I'm doing, like when I worked on this stuff, I was doing a lot of research into these different ways that the brain works, right? And so I created in the real world, I created all these stacks of papers, and I had sticky notes, and I'm a little weird, so I had strings going between sticky notes and things like that, right? But then when I'm done with the project, I have to like put it all away somehow because I don't have infinite space. Well, if I was in the digital world, what I could do then is put it away and then come back the next time I want to edit this presentation, and I can go, boop, and it has its spatial meaning to me, and then I can boop, right? So it's kind of like a scalable canvas of space that I can stretch and close however I feel I need to do for that moment, and it's so pliable that it's never going to break it, right? It can be as chaotic or as ordered as I need it to be in that moment.
Okay. Thank you very much.
Thank you. Oh, sorry.
Yeah, in that answer, actually, you're using a lot of verbs that kind of suggest adding a bit of physicality to the user interface. I've seen some demos where you have a cube with your UI mapped onto it, and you can kind of spin it around to access other modes, or it may be attached to an input device, and it's moving around with the input device and kind of bouncing around with other virtual objects in the scene. Do you, like, how do you feel about that having the physicality? Does it ground the interface in the scene, or is it not very functional or useful to you?
To me, physicality is key, because that's how we understand space, is by moving through it and by interacting with the objects physically in space. So if we aren't allowed that freedom of movement, that way of understanding what's happening there, and part of that is picking up an object and turning it around and being able to put it back down, then we're missing a huge part of what would make this powerful. So absolutely, that has to be in there, I guess. Yeah. Thanks. No?
Hey, I've seen various projects related to augmented reality, like letting people tag physical things in the real world, and it just made me think, like, do you believe in this vision that our real world will be tagged with digital content? And if so, is it going to be, because eventually we'll be walking around with augmented reality glasses, possibly if HoloLens and things like that evolve. Does that make sense to you? Is that something that you think is desirable for people to have, like, digital content embedded in the world, and will it be shared content, or is each person's world going to be augmented separately? And I mean the public spaces, less, you know,
Sure.
in the home, it's obviously more a personal thing.
Sure. Well, I think it's kind of like how we use public spaces now, right? Like, I could walk into a crowded room and I could choose to just be in my own little world there and ignore what's happening because I'm focused on my book, right? Like I don't have to listen to all the conversations around me. Or I can choose to engage in that space. I can choose to have a conversation with this person or that person, or I can choose to, sit down or move around. It's up to me. And I think that it's really, augmented reality is very much about getting my chocolate and my peanut butter and my peanut butter and chocolate, right? Like the whole point of it is to allow me to use my understanding of the real world in a superpowered digital, somehow superpower it with digital power, the digital magic of it all. So if I can't tie like a manual to this speaker that's there at my touch, right at my fingertips, then I don't know, I can't imagine an augmented world without that. I think that's really key. The question becomes, is it kind of like our computers are now, which is this is a whole nother talk, by the way, like our computers are now, where everything is screaming everything at you all the time, like all of my options are available to me all the time, or are we using it intelligently in thinking about the way the human is, like, what are you looking at? Are you talking to that, or are you talking to that? So if we can start to understand intent on the human's part, then we can strip out a lot of the interface noise that I'm terrified will happen.
And also who will regulate this content, this digital graffiti that people will be leaving in the real world. Kind of like Google tried to open their maps thing for people to annotate things, and then that was abused, so they recently shut that down. So
right.
It's going to be a similar thing, possibly.
Right. Humans, man, they're always screwing everything up. Okay. All right. One more? No more. Oh, sorry. Okay. Thank you, everybody. I'll be around if you want to talk after.